Hey guys, we're doing some aluminum work today. I'm building some aluminum spray bars. This is for an agricultural application. Um, but I figured since I'm doing some aluminum work today, I would do a video on just like the basics of aluminum welding. Aluminum's one of my favorite materials to work with. It's just super lightweight, corrosion resistant. So it's a really good choice for a lot of applications. Things like this where corrosion resistance and being lightweight is a real plus. It's a great choice for that. Also things like marine applications. So there's some real fun things you can do with it. I like it because you can build stuff for the boat. You can build it for outdoor applications, truck racks, whatever you want, and it's going to hold up to the elements and not add a lot of weight to, whatever you're putting it on. So, besides the actual applications of it, it's just fun to weld, in my opinion. I love the fluidity of the puddle. It's got a real low melting point, so the puddle's real fluid. And when you just have the settings dialed in, you get this real like mirror look to the weld pool, and it's really fun to weld. And it's kind of a fast-paced welding too, as far as with TIG welding, dipping and stuff like that. So I like that about it too. So one thing about aluminum welding is that a lot of times when people try it for the first time, if they're not familiar with the properties of aluminum and how that compares to, say, like TIG welding, mild steel, or even stainless steel, there's some things that you have to know before getting into welding it, or else it'll just be a complete disaster. Things like cleaning the oxide layer. The aluminum itself has a very low melting point. It melts at about 1200 degrees, but the oxide layer, so just this layer that builds up on the surface just from reacting with the atmosphere, that has a much higher melting point. It's like 2600 degrees, right? Or 3700 degrees. So if you don't clean that oxide layer by wire brushing and cleaning it up with some solvent, then that oxide layer just sits right on top, and it makes it nearly impossible to weld, and you'll just have terrible results. So you need to know that going into it. Also, there's some other things. Heat moves very quickly through aluminum, so you're going to have the transfer of heat away from the welding area. So on thicker sections of aluminum, that's an issue. Also, you're going to have higher distortion rates. So when you're doing fabrication with aluminum, you have to compensate for that, and you have to plan ahead for that. Just for instance, on these spray bars, when I build them, I'm welding all these NPTs on one side. So I have to backbend. Once I get them all tacked, I backbend the pipe, so that when I weld it, after it cools, I release it and it all comes out nice and straight. So those are some of the things that you'll need to think about with aluminum. Other than that, those are basically the things that you need to think about before welding aluminum. And once you know those things and you're preparing for those things, it's going to come out a lot better, and it's going to be a lot easier. And you'll find after you do it a few times that you'll probably really like it too. And it's just a great skill to have under your belt, to be able to branch out and do other types of materials if you're already pretty, proficient with carbon steel and things like that. So anyway, we'll get to it, and I'm going to do a little bit of work here, and then I'll just show you some basic welds, how to prepare the material, and a few basic welds in aluminum. So the first thing that's going to be very important about welding aluminum is the preparation of material and the cleaning. If your material's not clean, you're going to have a very hard time with your welds, and you're going to have very low quality to your welds. So not only do we have to clean the material and try to keep the material as clean as possible, you know, your storage of your material and things like that, to avoid cross-contamination with carbon steel and things like that. But you know, also the cleaning of the oxide layer before you start welding. So I'm going to go ahead and show you the process for that. So this is a piece of material that I have that we'll be welding on. As you can see, you know, it's not perfect material. It's definitely has it's definitely a little bit dirty, has some contamination and stuff like that. So for material like this, I'm going to take some extra steps. If the material was not, you know, was perfectly clean and had, you know, plastic coating on it that you peel off and it's brand new, then you don't really have to take as much precaution. But with something like this, I'm going to go ahead and clean the surface with acetone first. Just clean off any, you know, residue or grinding dust that's settled on it. We're going to clean that first with acetone or isopropyl alcohol. And then we have some dedicated brushes that are just used on aluminum. I have two different brushes here that you know, I keep in my toolbox that are designated just for aluminum. These are stainless steel wire brushes. So they have stainless wire, and that's what we're going to be using to clean the oxide layer. So any area where we're going to weld, so on this one, we will be doing just some surface welds. Any area that I'm going to be welding, we're going to want to clean that oxide layer. So all that we're going to be doing is using a nice even pressure, and just basically we're just breaking up that oxide layer which is on the surface. And we're going to do that any area that we're going to be welding on. We don't need to press really hard, because that will actually embed that oxide that we're cleaning, that we're breaking up. It will embed it into the soft material underneath. We're just using a nice even pressure and making sure that we're cleaning all the areas that we're going to be welding on. So you can see that there's a big difference. You can tell the area where the oxide layer is broken up by brushing, and the area where the oxide layer is still there. You sort of have this difference in color. You can definitely see this is ready to be welded. So again, extra precaution. I'm just going to go ahead and wipe it down with acetone again, clean off some of that extra oxide that we've broken up. Just going to wipe that off again to get this nice and clean. Again, that's not going to be necessary for material that is very clean to begin with. You know, some material you're going to be able to just grab it, give it a little brush, and go to town. This I'm taking a little extra precaution with, just because it is pretty dirty. So now this is ready to be welded. So we're just going to be doing a surfacing weld on this 1/8 inch aluminum. So I'm going to take you over and show you how we're going to set up our machine. We're set on alternating current, and we have it set on GTAW here. Remote for the foot pedal. Our output control is going to be on remote for the foot pedal. And then here we have high frequency, where we might be using high frequency start on carbon steel. With the AC on this type of machine, our older synchro wave, we need to have it set to continuous so that it keeps the arc stable and keeps it going between you know, both sides of the wave. The newer machines that are inverter type machines, you don't have to worry about that. They switch so quickly between the different sides of the wave that you don't have to worry about high frequency continuous on those. My amperage, I'm going to set this to about 120 to start with. We'll see how that works. I typically like a little bit more amperage because I like to get to a weld pool a little bit quicker. The only kind of advanced settings that we have here would be our AC balance, which on this side would be maximum cleaning, which you can see here, and on this side would be maximum penetration. So this is the percentage of time that it's going to be spending on each side of the wave, meaning, you know, one side of our AC wave is DCEN and one side of our wave is DCEP. Those do different things. And when I say DCEN, I mean direct current electrode negative, where your heat is focused in the base material, or DCEP, direct current electrode positive, where most of your heat is focused on the electrode. Those sides of the wave, as it switches, do two different things. DCEN is going to give you more penetration. DCEP is going to give you more what they call cleaning action, which is the cleaning of that oxide layer that we were talking about. But it's also going to give you more heat on your electrode, which, you know, is going to put more stress on your electrode, is going to change the shape more quickly. So typically we don't want as much of that. But it depends on what the application is and whether we want more penetration or more cleaning action. In this case, we're going to set it about 70% towards the penetration side or the DCEN side. So that's what that would look like. That it's about 70%. Okay. Then my post flow, I have it set at about 10. So that's T2 would be about 20 seconds per post flow. Okay. In terms of my torch setup, I have 3/32 tungsten electrode. This is a 2% serrated electrode, which will be fine. I have a number 7 cup and a gas lens. So that's my setup. You can see my my electrode is just tapered. I have a little bit of a flat at the end. That's going to round off a little bit anyway, just because we're using AC, and some of that wave will be on the DCEP side, which will put a little heat on the electrode and round it off, and that's okay. So that's my setup. I'm going to run about 25 CFH on my gas. I'm using 100% argon, and that's about it. So here we go. So I'm going to go ahead and start, and the thing to remember when you're first starting is you really need to see this weld pool first. So as I start, I'm going to give this, the amperage a chance to get the weld pool started before I start dipping rod. A lot of people will just start dipping right away, and that's not going to work right. You know, your filler metal is just going to kind of melt right on top. We need to get a weld pool and then dip our filler metal into that weld pool. So here we go. So the cleaning action is just starting to work now. We don't really have a weld pool yet. Now we can start to see that weld pool forming. We're going to dip in and move forward, dip in, move forward, dip, move forward. Just keep a nice steady pace as best we can, and just dip our filler metal in as we move forward. right, so this is basically our surface beads here that I put down. And, you know, so I was kind of narrating while I was welding, but I'm not sure how well that's going to turn out. So I'm gonna say it again here. And basically at the beginning of the weld here, you know, when we first start the arc, we're going to see sort of this the same thing you see around the edges here, which is the cleaning action. Is this sort of blotchy, you know, look to the material, and that's going to start to form first. And a lot of people mistake that for the weld pool, so they start dipping rod right away. And we don't want to do that. We want to wait until we see the sort of mirror forming of the weld pool. That's when you know that the material is actually melted, is when you start to see this reflective surface, which is the weld pool starting. Once you see that, then you can start to add filler, okay? A lot of people start to add it too soon, especially when they first weld aluminum. They'll start to add filler, and then it's just gonna melt right on top, and you're not really gonna be getting a weld. You're just gonna be balling up your filler metal, and it's not gonna work out. So once I get that weld pool started, I add filler, put in a nice dab there, and with aluminum, you know, it's gonna shrink on you, so because it has a lot of shrinkage from heat, you know, as it cools. So we want to, you know, put a pretty healthy dab in there, you know, kind of push the material in as we dab it in. So we dab in and then move the torch forward, dab in, move the torch forward. Each one of these ripples is how far I'm moving the torch forward. And it's maybe a third of the overall weld pool. And I'm just doing that as I go all the way through. And then towards the end of the weld here, we have our crater. And because of that real heavy shrinkage that we get on aluminum, we need to be careful of developing a crater. So at the end here, we want to add a little bit more filler, which I actually have a pretty good dimple here. I try to do a little bit better job next time. But basically, we want to try to eliminate this as much as possible, because this is where a lot of cracking that develops in aluminum will start, is in this crater. So we want to add, you know, if we're dipping once here at the end, we want to maybe dip twice or 3 times, add a little bit more filler, and then slowly back off of our amperage until we terminate the arc. And one thing that I would recommend if you're just starting with aluminum, start doing this first, meaning this type of surfacing weld. Get a nice piece of plate that's maybe a little bit thicker, at least 1/8 of an inch or something like that, and just surface the entire surface of this plate. And that will really, you know, of course, yours probably aren't going to look like this when you first start out, and that's perfectly okay. But when I first started welding aluminum, I just had a piece of plate like this that was a little bit longer. And all I did was I just surfaced until I really started to get the feel of it and the kind of rhythm of dabbing on aluminum down. And I just did, you know, side by side. I just surfaced the whole surface, front and back, and I ended up with several layers on there, so it got pretty thick. And but by the end of that plate, I was ready to move on to other joints, and I was a lot more confident. So I would definitely do that. And then, of course, another thing that I would take a look at is whether you're getting burned through or not. Like I said before, you know, you have a real low melting point of about 1200 degrees. So if you reach that 1200 degrees all the way through this plate, you're going to get melt through. And so that's a good way to gauge if you're moving fast enough, if you're maybe using excessive amperage. That sort of thing is by if you're getting melt through or not. So check that as you're going as well, to kind of gauge how you're doing and if you need to make any adjustments. Okay?
right, so just ran a few more beads here to show you this surfacing technique. You kind of want each bead to overlap the other one, and just surface this whole plate as you go. And again, that'll give you a lot more practice and kind of get that dabbing technique down, and just get a lot more comfortable before you move on to other things. And it conserves material when you're in that practice phase, so that works really well. All right, so now I have a T-joint tacked up here, and I have this prepped the same way that I did the other one. As you can see, the areas that I'm going to be welding in, so I haven't really done any brushing out here, but in the center of this plate where my weld is going to go, I brushed, and on the end of this this top piece, I've brushed as well. So only in the areas where you're going to be doing your welding, and then I did clean it up with acetone. One thing I wanted to mention with tacking, it can be difficult to tack aluminum. And one thing that I've seen people do a lot is they'll brush the area that they're going to weld, but if they're going to tack on the end like this, they won't actually brush this area. Well, there's oxide layer on this area too, which makes it hard to melt. So if I'm going to tack here on the ends, I also brush the end of the plate where I'm going to be making my tack, and it makes it a lot easier to put that tack in. Okay, so I'm going to go ahead and weld this T-joint. I'm at the same settings that I was before at 120 amps. You do have a little bit more material there on the T-joint, but I did have some excess amperage that I wasn't using on the pedal, so it should be fine for the T-joint. Okay, in terms of my torch angle and stuff like that, if this is 90 degrees on my travel angle, I just want to kick it back about 20 degrees or so. I'm at about 45 degrees to the joint in terms of my work angle as I go forward. So it's going to look something like this as I go forward. And the thing to keep in mind, with all types of welding, once you lock in this angle that works well, you've got to maintain it all the way through. So, it needs to be like your hands are just strapped in on a track, and they are not going to move. You need to make sure that you aren't pivoting this angle as you go through the joint, because then you're going to see that in your weld and you're not going to get good results. We need to lock in these angles as we move forward. Okay? All right, so let's give it a shot here. Alright, so here's the finished weld. I ended up going up to 130 amps, just wasn't hot enough. And it, quite frankly, could still be a little bit hotter. The toes still look a little cold, but overall not bad. So that's the fillet weld there. So here's a little butt joint prepared the same way. I have 3 tacks on there because that little gap that I've left there we'll want to close up with aluminum, especially. A lot of shrinkage and a lot of distortion. So that's one thing, is some extra tacks that you can put on there to compensate for that. All right, so here's our butt joint, and came out pretty good. I'm at 135 amps on this one, and it wetted out nicely, so pretty happy with that. One thing I wanted to mention too is safety with aluminum. There's no heat color change. So although looking at this plate here, you can't really tell if it's had any heat to it because there's no color change. Mild steel, it's like you weld it and you see the heat affected zone, and you could tell, okay, well maybe this thing's hot. This you can't really tell if it's hot or not, and I assure you it's very warm right now. If I were to pick this up with bare hands, or even with my these thin TIG gloves that I have here, it would not be fun. So I just wanted to mention that there's no heat color change, and also the heat moves quickly throughout the entire part, whereas some other materials, the heat will be more localized. If you're welding an aluminum part, the heat will move very quickly throughout the entire part. So if you're resting your arms and your hands on there, they're going to heat up pretty quickly. Alright, so I hope you've enjoyed this video. This is meant to be a video for those of you maybe just starting out in aluminum and don't know the basics, so it's by no means a super advanced aluminum video. Maybe I'll do one of those in the future, but quite honestly, there's people out there who are a lot more experienced than I am in welding in general, so I'm not going to pretend like I'm some huge expert on everything. But I make these videos to help out people who were like me when I first started out welding and needed some help and just kind of had to figure it out on my own. Hopefully videos like this will be helpful to you if you're just starting out, trying to get into the welding industry, or even if you're just trying to build some cool stuff in your garage and just like fabrication and that sort of thing. So hopefully these videos are helpful to you. If you like the videos, please give it a like and subscribe to my channel. I'm trying to get the channel to grow a little bit because I'm really enjoying what I've put on there so far, and I want to continue to do it. So please give me a like and a subscribe. I'd appreciate it, and we'll catch you next time. Thanks.